So, about a year ago, well, actually even more than that, beginning of 2017, I started receiving well, messages from people I know that have worked in the blockchain on Ethereum, some old friends, and telling me that I should really start looking into Ethereum and smart contract because the state of the toolchains and the languages there is really bad, and that's something that Red and our team could be doing something good for that. And I was very reluctant at the beginning because I was not well following that from far away and not very particular interest into that domain. Even if I mined some Bitcoin in 2009, just for testing, I guess, for like many people at that time when I first read about Bitcoin on Slashdot in 2009, and it was just at the end I started like mining for 2 days just to test it. I mined something like 0.01 or 0.02 Bitcoins, and then I just deleted my wallet. Yeah, no use. At that time, it was not convertible to fiat money at all. Nobody was talking about that actually at the time. And it was at the end. It was at the end of the free giveaway Bitcoin period, where they were giving for like 10 Bitcoins for anyone willing to do something or test it. Or so I just downloaded the Bitcoin client at that time. Like that was like 1 or 2 days after the end of the free giveaway Bitcoin. And so I just found the tech really interesting, but just as a lab experiment, not as something that could be used in the real world, or not in the short time frame. And so in 2017, people start telling you should look, and people repeating us that we should look. So at some point we had a look at that. And I was quite horrified by what I've seen on Ethereum. At the same time, I was very interested by the concept itself of running code in a trust environment that's replicated and secured with an underlying blockchain. That was really very interesting and very intriguing concept. And actually, we are, since a long time, because we're old people, since a long time we believe in the decentralized model. Way before Bitcoin and other stuff like that, we started using internet in '93 in universities, before it was even public. So we know what are the roots of the internet and what internet should be. And the web messed up a lot of things. Brought a lot of good things that messed up a lot of things, and nowadays we end up in a very centralized model that is a big problem. So the big players, Google, Facebook, and others, are creating a lot of issues and having too much power and too much control over that. So bringing back the basics and the original vision of what internet should be, so a purely decentralized P2P model, is something we really believe in since the beginning. The problem with a P2P approach and a decentralized network is that you are not using the resources of a company or an organization. You are using the resources, a little bit of resources of everyone. So if I plug my computer on such network, on a P2P network, and allow people to use my disk space, my computer power, electricity, my bandwidth, my internet access, well, that's cost me money, real money. And you cannot have an easy system using, for example, credit cards, Visa cards, to pay everyone on the network you are using the resources from. So it's not a model that works with the current financial tools that we have. So cryptocurrencies and Bitcoin could be and probably is the missing piece to make the P2P networks and that model viable. By paying, using this virtual money, decentralized money, currency, all the resources that you are using on the distributed network. So it makes sense. And And that's the first reason why we started looking to Ethereum at the beginning for that purpose. And the smart contract is just the icing on the cake. It makes the transaction programmable. So you can do a lot of stuff instead of just exchanging cryptocurrencies. You can do really some interesting things. But the problem is that the EVM was, like said during the conference, it was built by cryptographers. It was not built by VM experts.
Unfortunately.
So that creates a lot of problem, and there's a lot of design flaws. Well, a lot. There are some design flaws, more or less important and more or less critical, and there's a lot of design flaws in the language Solidity that was built by cryptographers again, Gavin Wood and his team, and not by language designers.
Yeah, unfortunately.
So Solidity, which is 99% of the smart contract market now, well, it's an obstacle for the spreading of this tech and finding the good use cases for that. So since last year we studied that, and we thought there are huge pain points there. First coming from the Solidity language, and then from the tool chains. So at that time it took about like 1 year ago. It took to our friend who's very well versed into programming on blockchain and Ethereum. It took him like 2 days to set up Ethereum toolchain. And the Solidity guys, so that we met from the Solidity team, at that time they said that it takes them 2 hours to set up a development toolchain for Ethereum.
Even them?
Them, 2 hours to set up. So since then we really thought that these huge pain points, both at the toolchain and language level, are something that we can address very well, because that's exactly what we are fighting against since many years. So we know how to fight these things and how to bring some value there. So we thought maybe we should design a DSL for that, and try to interconnect this blockchain and this P2P network into the RED ecosystem somehow, and giving people a new tool to play with. So a new component, and we call that C3 for now. So it stands for cross-chain code, because at the beginning we said, why limit to Ethereum? There are other blockchains that are smart contract capable, so we should have a DSL that can compile with different backends to different blockchains. And then after digging a little bit deeper, we realized that actually no, there's only one that is worth working with, it's Ethereum, because so we considered iOS, we considered Neo. We had a meeting with the Neo team, Dang Fei, and the technical team, Eric Zhang, I think was his name. And we realized that actually what we are building is just a very, very bad copycat and remote copycat of what Ethereum is trying to achieve. So we don't believe that they have the right approach at all, and they're just lagging behind. They're not doing any deep research about all these things. They're just trying to, well, grab whatever they can from other projects, and mostly from Ethereum, and trying to take some shortcuts. But there's no shortcuts in that in order to build something that can really sustain.
Sorry, are you talking about Neo or EOS?
Neo. EOS, EOS, I haven't looked that deep into that, but I was very, repelled by the excessive PR we were doing. And each time I tried to learn something about EOS, there's this a lot of marketing, excessive marketing and PR layer that makes it like not very serious to me. So that's why we did not look deeper into that. I think they're using Wasm as a VM. Is that right?
I think this is not ready yet, but
oh, really?
I also have a very superficial understanding.
It's very difficult actually to obtain some technical information from this project.
They have a lot of money. I mean, they are going to build something for sure.
Oh yeah, they have a huge amount of money. That's for sure. Yeah. But like the guy in the desert that's building a new crypto city in Nevada, you've heard about that, the blockchains project. They made an announcement 2 days ago with the holograms in Prague. You have their advertisement in the subway everywhere. So they bought a huge area in Nevada next to the Gigafactory from Tesla, and much bigger area. They're actually surrounding the Tesla factory, and Google also start building something there, and so they're just surrounding them. They bought a huge amount of terrain, like land, like half of Prague, and they want so they revealed the project yesterday or 2 days ago. So the project is building a crypto city. Just that. So a new city where all people can come there, pay no taxes, because in Nevada you don't have to pay taxes, and everything runs on crypto, especially Ethereum. And the whole city is built on using this kind of infrastructure. So they want real people to live there. So from the desert, they want to rise a big utopian world. The guy is very rich, extremely rich, and well, he wants to try that dream. And in his main interview, he said that will be one of the most amazing achievements in the history of mankind, or one of the biggest failure. But I still don't know which one. So there's a lot of crazy things happening in that crypto space. A lot of PR that is clouding everything, and we don't like that. We are engineers and tech people. We just want the meat. We don't want everything, all the PR on top of that. When we try to see through the cloud, it seems so far that Ethereum is the only real credible architecture that has a future, and very bright people, very smart people. We talked with many of them from the Ethereum Foundation in the last days. Very smart people working on that for solving very hard problems. If these guys are not capable of solving these problems, nobody will. So at least that's how we understand that space. So what we can help with is building a DSL that makes it simpler for smart contract building, and trying to fix some of the mistakes made in Solidity at the same time. So make it safer. So basically, we build it a bit like some parts of Red software stack. We think that one DSL might not be enough to address all the needs there, and we probably need at least 2 or maybe more DSLs. We are not yet sure about that. So the basic DSL, we call it C3 system. It will be a Solidity level language, a bit more restricted than Solidity. For example, no inline assembly allowed. I don't know how many of you have written Solidity code. You, 1, 2. You just look a bit at it. Yeah, so it will be Turing complete, like Solidity, but we will put a lot of safeguards around that. On top of that, we want to build a higher level DSL. So that's quite challenging. We want it to have very limited semantics, so something like the VID DSL we showed for GUI development. We want it to be Turing complete, because we want this language to be, if possible, usable by some power users, not necessarily programmers. So we want to allow people, for example, who are capable of mastering Excel and writing complex formulas, maybe even a little bit of VB macros, to be able to use this kind of language to express their rules for smart contracts. And we want this high level to rely on the low level. So the high level components, if there are any, to be written with the low level language. So mostly I will explain you the C3 systems, because the C3 itself, the high-level version is not, the design is not finished yet, and I can show you some example of what we are trying to achieve at the end of the slides. So our goals is to be human-friendly, so addressing the usability problems, because that's our first concern in RED. In pretty much in everything we do, we really think a lot about usability. Oh, finally, you skipped. So we want a rich set of data types. Why? Because, well, because it comes for free. When you build a DSL on top of RED, you have many of the RED data types that you can use for free. It doesn't cost you pretty much anything. So we can make it much richer than Solidity. We are still limited by the same restrictions on the EVM. So there are many data structures that we would like to add. We cannot because the cost of these structures is too high, the gas cost for them. We want safety. We want high safety. So you will see there's several features, security features that we really want to make as first class. Of course, arrays, bounce checking. We want a compiler that is short because we would like to make it, well, because it needs to be easy to maintain and to evolve, but it needs also to be easy to be analyzed and eventually formally verified. We want a dead simple toolchain, of course. So 1 megabyte is the upper limit. It probably will be around 3 or 4 kilobyte. So each time I say that, I'm not sure people, other programmers, are taking me seriously, because I'm always, often I believe that programmers think, wow, what, 300 kilobytes? Well, that's nothing. I mean, that tool is probably so limited that there's nothing very interesting. I mean, 300 kilobytes, that's ridiculous. So sometimes I'm afraid it won't be like taken seriously. So we are thinking since yesterday to add a new compilation command line option called dash bloat that will make 50 times bigger executables.
No,
so
configurable. You can make it whatever size you want.
Yeah, so that people might take us more seriously. Oh wow, 50 megabyte that must be powerful. We want to have a EVM simulator. Why? Because the EVM does not have any debugging mode. It has a tracing mode. So basically you can run contract execution and get a trace of all the assembly level instruction execution, but you can't really, well, do a step-by-step debugging and have, Remix. Some tools like Remix allows you now to do that. It's still not that easy to use or not very readable, but still it can do some pretty good job. We would like to do something more user-friendly for that, and having a debugger that is source level, not bytecode level. And we want to have a generated test framework because we can, well, the smart contract source code is usually a few dozens or 100 lines of code. It's not that much. So it means that you can spend more computer time on doing a deep analysis of the code and eventually going through all the code branches and just generating a lot of tests to test for the use for the edge cases. So you can have a tool that will go through the contract and generate a lot of unit tests automatically for you. And that can be very helpful in this domain.
Did you tell them we got to meet with the teams?
We met with the Solidity and Viper teams. We had a private meeting with them.
So on the debugging side, it was interesting. A couple things. Some of the stuff we're talking about may come in Constantinople, the new release, when that eventually happens, to help reduce some gas costs, which we've already planned optimizations for. And Christian Reitwiesner said he still wanted us to do our experiment because he wanted to see how it worked out, even if Constantinople made it kind of obsolete.
Yeah,
but
yeah,
they also
we have a kind of, we were thinking about some kind of killer feature to have, which is buffering all the storage accesses, because the storage accesses are the most expensive operation in a smart contract. A storage access is, first access is 20,000 gas, while some simple instruction at the level of 5 to 10 gas cost. Memory access was 100. I don't remember exactly the numbers. I think it's around 100 gas for one memory access, 20,000 gas for one storage access, so permanent access. We are talking about one word, so it's 256 bits.
And 20,000, it is a lot. It sounds like a really high number. For those not versed in the blockchain space, they express things in two types of values, ether or Wei. And Wei is 18 decimals out. So a gigawei is still 9 decimals out. So they're tiny, tiny, tiny values that end up making some numbers look really, really huge. But the other thing that we talked about there was their new intermediate language, Yule, that they're targeting. And that it's got annotations to aid in source debugging. So we can target the EVM directly, but we could also target Yule to help them debug it and flesh it out because nobody's really using it yet. And Alex said that that would be very helpful if we could target it and give them feedback on our view of it, because the source annotations, even the Viper team didn't know how that was going to work for them.
Yeah, for now we are, the compiler emits directly bytecode, EVM bytecode. We don't have Solidity or any other kind of intermediary layers, but we might consider eventually Yule, that's proposed by the Ethereum Foundation as an intermediary layer, because they are working on optimizers on that. So maybe we can have that as one of the backend of our compiler. We'll see. For now, we just focus on the bytecode. We don't really trust them to do bloat-free solutions. So for now, we'll build our solution, and if their solution, if their backend is good enough or fits our needs and constraints, maybe we'll use also their backend. So compared to Solidity, these are some of the points. So we have, of course, SafeMath built in because that's so obvious. So we have one data type that's called money. So the one that we already have in red. So that money data type has SafeMath in it, and that's the one you should be using for any currency operation, so that you are safe using it. Of course, no recursion or reentrance. We enforce that at both compile time and runtime. So we have a flag. We have a bitmap somewhere where we just flag when we enter a function and deflag it when we exit, so that we know if we are already, this function is already run. So if even using a delegate call, so if a contract calls another contract and that contract calls back that same function, we can detect it. This kind of reentrance, remote reentrance in the same function is known also as the parity. What was it? The parity bug? No, it's not the parity. It's the.
It was the hack.
Parity is the multisig.
Yes, parity actually had 2 or 3.
At 2 or 3.
Yeah, multisig. Then they fixed it and had another bug in that also. But yes, you're talking, I think, about DAO.
That was the DAO hack.
Oh, the DAO hack. Yes.
Yeah.
The DAO hack was a reentrance, and it costed 50 millions.
I forgot what it was.
Something like that, $50 million, and resulted in Ethereum hard forking, and the Ethereum community splitting in two, with people continuing with the old version of Ethereum called now Ethereum Classic, and the new people with the Ethereum Foundation building the new branch. Just because you have this loophole where you could do the reentrance, and by doing that and very quickly, you could abuse the code and just steal the money.
So the functions, when they're deducting from accounts, because not everybody here is on the blockchain side, it's not completely atomic within a function. So before you return, somebody could call it again and just keep deducting before the returns would all happen and drain all the money that way. So it seems awful to have to restrict a language when we think in terms of general purpose programming languages. Why would we eliminate recursion? Recursion is so useful. How will functional programmers ever use the blockchain if they can't use recursion? They won't loop. But safety is absolutely the first priority here, because huge amounts of money are at stake. Yeah,
actually one of the main design flows of Solidity language from the beginning was to they have the goal, they had the vision of making Solidity as open and as capable and flexible as possible so that they can address as many possible use cases as possible. And that results in all the, well, so far this year it's $1 billion lost, stolen or destroyed. Accidentally, sometimes destroyed. Oops, I made a mistake. The famous.
It was very interesting. They had a panel with a lot of the EVM people, some formalists, people working deep on the EVM, and the current Solidity team are great guys. They inherited this language design, so this is not on them.
Yeah, the current Solidity developers are really serious people and really skilled people.
Yeah, but Greg Colvin, who's working on the EVM deeply, he looks like Gandalf. He's got a big beard and long gray hair, and he said the problem with the EVM, and it applies to the original Solidity design as well, is that they were designed by cryptographers.
Yeah.
And that the EVM is a great virtual machine design if this were 1960. Because it has dynamic jumps, like a computer go to in Fortran was his reference.
No.
So you can't formally predict where it will go anywhere at any time. And so they had a completely different set of ideas and priorities than what we're trying to solve with finding real-world use cases and what it might be used for.
Yes, so we don't allow inline assembly, we don't allow inheritance. We try to enforce a design by contract approach. Oh, by the way, important thing to say. When we say smart contract, you should forget the contract is a very misleading term, and they should have corrected that since many years, but it was good for marketing and PR purpose. When we say smart contract, it's not about legal contract. It has nothing to do with legal contract. It's just about code. So when we say smart contract, think stored procedures. It looks more like that. So Vitalik corrected it in a tweet recently. He said, I should have called it persistent scripts. I think stored procedure is fine because that's pretty much what it is. So it's code that is very close to the database and allows you, it's sandboxed, so you cannot do IOs or whatever you want with it. You can just read write on the database and you can control the accesses on the database. That's pretty much that. So the ABI is also terrible in Solidity. There are so many bad aspects that. Okay, so the ABI on Solidity, in order to call a function in a contract, you need to calculate a hash. You cannot just call a contract using the function name. That would be too easy. So you have to calculate a SHA-3 hash of the function signature, so the function name plus the list of argument types. Why? For bad reasons, actually. At the beginning, Solidity was using ABI with ID numbers. And that was, of course, obviously not a good idea. But just using IDs 0, 1, 2, 3. And then they switched to the hashing methods. Why? Because they have too many collisions. So in Solidity, you can overload functions. And you can also inherit contracts. So you can have name collisions. So in order to avoid that, well, you have to provide something else, and they're cryptographers, so they said, oh, let's hash that, and take the first 4 bytes of the hash, and use that as an ID inside the contract for the function. So when you call a contract on Ethereum network, given function, you need to calculate that hash. Otherwise, you cannot call that function. Makes it easy. So in our case, we don't have these features, so we can simply use the function name for calling in our ABI for calling a smart contract function for the entry point. We propose that at the Viper and Solidity developers, and they add heart attack. No, we should standardize. I said, but that's just the Solidity ABI. I said, no, it's the Ethereum ABI now. So I did not want to enter into an argument with them, but I don't see any good reason why we should fix this kind of wrong design decision that are caused by bad design decision in Solidity language, and have to carry that on. It's still early times. I think it's still time to make some fix or changes in order to avoid carrying that for many years in the future. So Viper it removes both function overloading and inheritance, so that Viper could very well use the same ABI as we do, a sane, normal ABI, and not the terrible one that's used by Solidity. But they just said, okay, we want to use the same as Solidity. We want to be part of the team.
We also have something related to this that isn't on our list that I think we're finally decided we won't have a fallback function in contracts.
We haven't totally decided on that
Yeah,
yet.
in Solidity you can have a single anonymous function, but not how functional programmers would think of anonymous functions. If somebody calls your contract and they can't find a hash that matches any of the function signatures, it falls through to the bottom case and will call that default anonymous function, what they call the fallback. And that has a lot of ramifications. They also have flags for functions to be marked as payable, whether you can send them ETH. And if you don't mark your fallback function as payable and somebody sends you ETH, it should revert. But if it's marked as payable, and correct me if I'm wrong, your contract will accept the ETH, but it has nowhere to go if you don't do anything with it. And it just vanishes. So there are things we want to avoid. If we want to make it hard for people to hurt themselves, which means more constraints and more limits.
So we will implement our own ABI, and of course we will also implement the Solidity ABI because we need to be interoperate with them. What else? We have access control list that are first class construct in the language. So instead of spreading around private public keywords everywhere, we just put that all together in one place where you can have a global view of the access rights to the different part of your contract.
And that also covers modifier cases for things like owner only.
So we limit the function name to 32 bytes UTF-8 for now because of the ABI. We need the function identifier to fit in one EVM slot, so we are limited to that for now. I think that should be still good enough limit. It's not too...
Except if you're an Objective-C programmer.
Yeah, if you're an Objective-C programmer, or maybe a Java programmer. I think Swift also has this kind of sentence. It's not normal identifier, it's a sentence inside. I'm not convinced that makes the source code more readable. Yeah, for the self-destruct, we want to find, it's not, the design on that is not really finished. We want to find some ways to make it more controllable by the user and make it more, how to say, visible that the contract can auto-destruct, can be self-destructed or not. We allow Unicode in identifiers until someone shows us a working exploit that use that. We will keep that because for now we cannot figure out any ways to subvert that feature in order to as an attack vector for the contract. So
I think it's more of a code maintenance thing.
I don't know.
accidentally typed a Unicode character that looks like a regular ASCII character.
No, actually, I don't want to interrupt you too much.
No,
I
we want to be interactive.
Yeah, I disagree when you said that the code should be like in native languages. I'm a programmer, and I prefer it if programmers from all countries just use English, please.
Of course, if you are sharing the code. But in the case of smart contract, usually, well, we'll see what are the use cases, but if you write your smart contract in a Russian company, I don't think that the people will like to read the code in order to verify that specifications have been implemented in English. Because the specifications are written in Russian, or in China, I mean, that makes no sense.
Will it be on this level, C3 system, or on a level above?
Both.
Both.
Maybe like if some developer for the company wants to steal the money from his company and he changes one character. And then
There's
No one
always
can-
going
He
to be
changed the
that.
name of the function, yes, so what?
If I understand correctly, if for the linguistic, so not even the comments with the Chinese, if they would like to comment something in Chinese or here they would like to comment in Czech language, that could be disallowed. Is that correct?
I don't know for the comments.
Because if
I'm not
in-
sure.
In the source code,
No, I think you can have separate rule for identifiers, separate
Yes.
for comments.
Yes, we have, for example, in string, Unicode is still allowed in Viper. They just disallowed it in identifiers. Okay, so we'll see.
But this is a really good point, and I'll jump back to Red in general to talk about this, because as we translate things, sometimes it's very hard to find the right word in translation. What exactly does that mean? And we want to be able to express intent clearly, that our code does what we want. So if we make people who aren't native English speakers translate, and not that an English maintainer will come in and go, no, that's not the right word, or I think I know what that means, but it really means something else. Let people think more clearly in their own language to express these things may also prevent some issues in mistranslation.
Yeah. For the types, so we have all the basic similar types. So integer we limit it to 64 bits for now, and it seems that EVM 2.0, if I remember correctly, will have some specific features to or was it Yule, to have some 64-bit oriented specific operation, because it seems that it's a good trade-off between the different possible sizes. So Viper use 128-bit integers. We are not sure that's useful because we have more types, so we can spread the different use cases over different types. So for example, if you have to express an amount in Wei, you can use the money or the Wei data type directly. You don't have to use the basic integer type. So basic integer is signed. The other types like money, Wei are not signed. I forgot to mention ether. Actually, money is a synonym to ether. We have address, of course, and we have a generic hash type that is the same as uint 256 in Solidity.
Don't they need signed money?
Signed money?
Yeah.
No, that's something that you don't want to have in a smart contract at all. People make a lot of efforts to never have a negative amount because that could cause so many bugs in the code. So it's just something that people avoid at all costs.
I had the same question early on though, and it means you have to use different math operators at times, and that may make things clear. But yeah, I thought the same thing. Because
No,
we're
you
so
don't
used
want
to
that. It's already hard enough to write safe code. If you have to support that feature, that becomes really harder. So we have a basic string data type, UTF-8 encoded, and for free we get many other string representations, so like tags, issue, email, URL. Why not? Because we don't know the possible use cases for smart contract and how far we can go. So we'll see what people can do with that. It's more expressive power. We'll see if that has, if people use it or find some interesting use cases or not for this kind of alternative way to express strings.
One example would be something like serial numbers. So you can use the issue for serial numbers. You have a contract that's generating license keys or something like that. And then you could have it incrementing, which would, of course, cost you as you're generating those. But then you don't have to go to an Oracle. You talked about Oracle.
Or yeah, or for example, you can have maybe you want to store in some mappings in or in the storage space. You want to store email addresses and maybe use them as keys somewhere, and you want to distinguish that from other kind of strings. So you can have a refined subtype for that. Maybe in some cases that can be useful. So we have a struct-like type that we call record for now. We have arrays and map, both fixed and dynamically sized arrays. We consider some extra types. We don't know for now if we will implement them or not, or if they are useful at all or not.
For the
Well, the unit might be probably useful. They do it in Viper. probably worth it, but it's not a very important type. So for now, we don't focus on it.
If we have the native types for way and money,
Yeah.
ether, we may not need that. An interesting point for the red programmers in the room who don't know the EVM, there is no real concept of arrays at all in the EVM. What you have to do is you have to use a map and add extra data on top of it
Yeah.
to track the index.
Yeah, basically
so arrays
the-
are actually much more, they're more expensive and more complicated than a
The
map.
storage in the Ethereum blockchain is a key value store. That's the only thing you have. You can't. It's not like relational databases where you can have records and tables. It's just key value. So if you want to store an array there, the underlying cost is pretty high because you have to map that to a key value storage.
And you cannot iterate.
You
over
cannot
the map.
iterate into that key value storage. Yeah. So these are the current keywords that some of them already implemented, but a lot of them not yet. So that's for C3 system. Well, that's pretty basic, the usual operators and control flow structures. We have bit shifting, but actually it's just math operation under this because for now the EVM does not support bit shifting. Too bad. I think maybe in 2.0 they will have bit shifting support as opcode because I remember some people requesting for that. Okay, that's basically that. We have some special kind of accessor. It's not sure that we will use this AND keyword. That's for now by default the one we defined because we did not come up with something good enough. We put a lot of energy and work in the naming. We try to find the right names, and it's very hard. It's one of the hardest, as you know, problem for programmers because the name needs to be on the point and at the same time it needs to be short. Cannot be too long because otherwise it's not convenient or too verbose to use and people research shortcuts. And we want to use full names. We don't want to use half words or acronyms or anything that is too esoteric. So I'm not very happy with AND for now, but that's what we have. We'll see if we can find better. So basically that gives you access to the meta information that you get in the environment of when you run a smart contract. So about information from the blocks, the current transaction, so the cost, the current caller address, the past amount, the current remain gas, and so on. So this is the kind of little bit formal layout that you can have for a C3 contact. Many of these are optional. So you can define logs, that's events in Solidity. The state variables that you can define in Solidity, we put them in a storage place. We hope that we can make C3 system avoid the memory and storage keywords that you have in Solidity, where you have to specify for a given variable if the variable is in memory or if it's in the database.
So who will decide? Compiler or compiler?
Yeah, compiler. The compiler decides because actually there's the killer. One of the good features, interesting features we want to add to that. We are still not sure if that's really possible to achieve. On paper it should work, but we need to implement it, make a prototype to see if it works for real, is to buffer the storage accesses in memory so that reducing the cost by maximally optimizing the accesses to the storage space. Solidity has a good optimizer, but the optimizer is limited to function visibility, function scope, so that it can optimize pretty well the storage accesses, reduce them, but only in a function. We can do it across the whole transaction, so across all the function calls, including the delegated calls. So if you are calling a library and using a delegate call and giving access to your storage space from the library. At runtime, we can, well, can we? I'm not sure.
We weren't sure.
On that one, I'm not sure on that one if that's possible.
Alex didn't think that was possible.
Yeah, yeah, maybe that one is too far away. But on the contract code, we can catch, the compiler can identify all these accesses, and we can optimize these by buffering all the write accesses in memory. And at the end of the transaction, just before exiting, we can have a loop that will process these memory slots and just write everything to the storage in one go. So that if you have multiple accesses across different functions to the same slots, you pay the cost only once. And that's very important, because mostly your contract cost is bound by the storage cost, because that's by far the most expensive operation you can do in a contract. So if we can achieve that, we should be able to have contracts that are cheaper than Solidity, which is an interesting feature. It's less important than make them safer, but it's still important because of some limits. When you run a smart contract, it's run on the Ethereum node, and that node runs it inside a block, so the block from blockchain. And these blocks have a limited amount of gas that your contract can use. So your contract has this hard limit. So I think currently it's about 8 million gas cost, right? So if your contract requires more than 8 million gas cost, it will never run. It will be rejected by all the nodes, and your code will never run. If your contract is using, let's say, 4 or 5 million gas, there's a good chance that it won't pass either. Why? Because you are competing with other smart contracts on the same block. So the block will accept several transactions, not just one. And so at the moment where your transaction or your contract code needs to be run in that block has already consumed some of its gas, allowed gas. So you might already have much less than 8 million available.
And the other important aspect of this is it won't fail the same every time. Sometimes it might work. It might work 90% of the time, and sometimes you'll be tailed on a block and run out. And that's unpredictable.
Yeah.
Completely unpredictable.
Yeah, so yes. So currently that's the state of things. Your transaction can fail in unpredictable ways. They can succeed or they can just fail, and there are many reasons why they can fail. And in many cases, it's not your fault. It's just because the state of the network at that moment is such that your transaction was not accepted, or just past the possible limit of a given block. So.
So even outside the scope of your single function or your single transaction, it makes it hard to reason about larger systems that are assembled that may have semantics related to at least once. You can't expect things to always work, and you can't roll things back easily across contracts. They're not atomic.
So basically, yeah, we have declarative here part. These are optional depending on what you want to do with the contract. So these are basically features that you can find in Solidity, but with a different syntax, different approach. This is a different feature. So access here, that's where you can specify access list. So basically, everything in your contract by default is private. In Solidity, everything is pretty much public. No, you need to still specify the public keyword for the state variables, right?
They are going to make it in new Solidity 0.5. It's going to be obligatory. You need to have to put visibility over.
Wow, that will make it even more fun to write.
And well, they have 3 or 4 keywords, right? Because there's
There are
private,
many
internal,
keywords.
external.
There are many modifiers. Yeah. So basically, everything is private by default. And when you want to allow accesses, you need to use this access keyword and use a mini DSL here to specify the accesses for functions or state variables. And so you can say, I want to give access to this list of function to anyone, or I want to give access to this list function only to this list of addresses.
Only
or
to the creator.
by default, everything is only accessible by the owner of the contract. So we have here the constructor, well, equivalent to the constructor in Solidity, so it's just an onCreate function that's optional. Then you can specify all your functions there, and eventually you can use the states keyword that will allow you to have a small state machine. So in many contracts, you want to build the contract as a state machine. That's quite common use case. And so for now, in Solidity, you have to do it manually. So it's not very convenient. We want to have really the ability to create a state machine, and the state machine can be entry point, then it's in the contract. So that when you provide the state machine keyword, you can directly enter the contract from the state machine. So the state machine will help you control the states more correctly and safely.
Could you elaborate on that a little bit? Yeah.
Well, maybe that one is a bit too
I have a
long.
little demo of
Okay,
the state machine dialect, so we can talk about that. We'll try to wrap up so we can do snack break.
Yes, and this for this state DSL, we did not yet finish the design. So there are still some questions about, for example, how to properly a good syntax for passing arguments when you are sending a transaction to that contract, and that contract is a state, given state. You want to pass some arguments there. So there's a language called Obsidian. Does anyone know about Obsidian? So Obsidian is one of the many experimental research language that some people are building for the EVM. And in Obsidian, so it's a DSL, it's a Scala DSL, right? And they express the states with arguments. So basically you have a big switch, and you express the cases or the states directly, and you have a list of arguments. So the state specification looks like a function signature, actually. So it's like embedding functions inside the big switch.
There's all combinations in the switch?
No. It's state oriented. So you have a implicit state variable, persistent variable, and then depending on the state, you are allowed to go into this or that state. Actually, I'm not sure in Obsidian how they handle that. We need to reread it.
It's tricky because if you dispatch to functions, you have to know whether those functions take the same set of parameters in every possible state, or define separate functions for calling that function from different states. So they would take a different.
Yeah, it's still a bit challenging to define properly something that is as a sound architecture, and at the same time simple to use, have a friendly syntax. That's not
as you
easy to
look
achieve.
at languages, for anybody interested in the smart contract space or different languages, Vladimir is your guy. He's spent a lot of time researching these and digesting information.
A couple of months ingesting.
You can actually see the languages leaking out of his ears. His head is so full of this stuff.
Yeah, he has
great.
a very broad overview of the whole space on that. So every project, significant project or serious enough project that's on that, he heard about it, and he has a long page. Maybe we should publish actually that
Yes, I think that was the
in a GitHub repository, because that could be very useful for many people.
You have mentioned the smart contract premise misleading, and that I actually took a wrong path in my research.
Yes, but we can extract the significant part.
Emphasize this financial aspect.
There's a lot of it that's really good and valid though.
But there's a lot of it that's still on the point, so we can extract that part and put it on a GitHub page. So that could be useful for people who want to see languages like Flint or Daml or other, maybe you've heard or not about these languages, and they are many actually projects that are trying to build some solution for smart contract programming with different approaches and different limitations. Some are very, very limited and very specific, and others are trying to be more generic.
Before we move on, the constructor is a very interesting thing in Solidity and in the EVM because it looks like it should just be part of your object. If you think of your contract as an object, you'd say, oh, it's a constructor, and every time it comes in, that constructor would run, but it's actually quite different. When your contract is created, that constructor is part of the code, and then the bytecode for the rest of your contract, ignoring that, is generated and stored on the blockchain, but the constructor itself and the code minus the constructor is returned to you, and that's your contract.
It's a bit like a microcontroller, actually. So
yeah.
Again, it's they took their inspiration from the 60s or 70s. So actually, the constructor, once it's compiled in the bytecode, it's like a bootloader. So it's run first. The first time the contract is sent, this code runs, the bootloader, and then the bootloader needs to return a pointer to the real code, so the rest of the code. So actually, when the compiler generates the code, it needs to put the constructor code at the beginning, or first reachable, and then, well, actually at the beginning, and then the rest of the code of the contract, the bytecode, below. And the bootloader code, so the constructor is run on the first run, and then it's discarded, and only the rest is stored on the blockchain and then will be called each time. And there's no functions on the VVM. There's no types, there's no functions. So that your bytecode is as a single entry point. That's the first byte. So every time you call a contract and you call a function, actually it's just calling the contract at byte 0, like in the old times, starting at the beginning and passing arguments. And in the arguments, you need to pass something that identifies which function. And you have a dispatcher at the beginning of your bytecode, and that dispatcher will check which one you want to call and then just jump. So it's quite specific architecture. This one is a very simple, like Hello World for C3 system. So it's not very different from what you will have in Solidity. It's just that we take some different approach for the syntax. But it's basically the same as creating an event in Solidity, creating a function, and just calling the event. Basically the same in this case. It's a simple example. This one is a bit more complex. It doesn't do anything real. We just use it for our design research. So it gives you a good overview of how to declare different data types. So for example here, these two constructs are arrays. So this one is a dynamically sized array, and this one is a fixed size array. Map looks like mapping in Solidity. There's not much. We tried many things. So we tried abstracting the map and array and struct data types into one, merge all of them into one data type, a bit like Lua does in with tables. I don't know if many people know about Lua here. So we tried that approach, merging all that in a single structure that we call record or table, and trying to design the language from that, and that was a failure. So we gave up on that. We could not have something that works in all cases properly with that. So we went back to what Solidity proposes with this split between struct, array, and maps.
Can you have maps of maps?
Yes, I don't think the compiler supports that in the release we will be doing soon. But in a later release, yes, we will support that. Because basically it's just the work on the compiler. It's just a feature of the compiler. It's not a runtime feature because there's only one map, basically. So it's just about the compiler doing some extra work for the keys, calculating the keys.
But that's also a key point when you have map string to person. If you have a map that contains a map, one of our goals is to reduce the syntax, eliminate extra block markers where we can. But sometimes we may have to add them back in for clarity of structure, because if you have nested maps, that could get very confusing very quickly.
So here you have an example of a function, no parameters, no argument, no return value. So here we declared a record. For now we use this template keyword. Not sure that will stay in the future versions, or if we will replace that with something else. So we instantiate this record using a make, and all variables in functions are local by default. So Rebelec will be happy. I know that's a big fight for him. In this case, that caused no problem for the compiler because it's not a runtime. There's no interpreter in this case, so to have no issue with making everything local by default. There's no conflict, there's no confusion, like in other cases. Here we just append, so this one is the array. We append the struct into this array. In Solidity, this kind of construct is actually not always simple because this array is stored in the storage space. But here you instantiate in memory. So you might have some complicated, sometimes the Solidity compiler will just reject your code there or say, I cannot do that, you need to specify some keywords here, like memory or storage, in order to make the compilation pass, and the compiler might generate in some cases code that will copy. So you will pay the cost for creating the structure in memory and then pay the cost for copying the memory structure into the storage. Here we are just setting the state variable. Which one? Yes, this one. From the record, we are setting the value. And then here, this is just a syntax for deleting actually the entry. So an array or a map, you just pass none. If you pass none, so none is not null. Don't be afraid. It's just a keyword that we use for these specific cases. In Solidity, you will use delete for that. We don't like delete at all. Why? Because it creates asymmetry between the way you assign a value and the way you remove a value. The syntax is totally asymmetric, so it creates some kind of it's not a nice design. We prefer to have the same syntax for setting or resetting the value. So we use this special keyword here just to say, okay, set this value to none, which is destroying it, basically. So you get, when you destroy your storage space on the EVM in smart contract, you get back some gas. So it's something you want to do in order to reduce the cost, the gas cost. It's a complex game. Programming on smart contract. You need to be both a programmer and an economist. Well, these are description of a bit more formal description of what you can, the syntax for function, but basically nothing. The syntax is a bit different, but you get pretty much the same features as you have in Solidity. So there's no big changes there. So this is some specification for now. This might not be the latest one for access, the access block. So above you have some specification using BNF, our flavor of BNF, and below you have an example. So basically, how it works, everything is private, and you can give some public rights to anyone with some restricted number of addresses. So for example here, I can give some access right to burn and mint functions to a manager address. By default, the access right is for the owner only. And here I can give access to anyone. Anyone is a keyword in this case, to these functions or to these variables, state variables. We think this design should work well but we really need to test that in real code. So writing a lot of smart contract code and see how this plays, because that's the only way actually to really know if these features provide more benefits than maybe constraint for the end user and the programmers. So we have a vast Red community, and so we hope that the people in the community who are interested in smart contract will be helping us, testing and writing some toy code to see how some features maybe need to be refined or improved or prove to be really good. We'll see. But there's always a difference when designing language between doing it in a lab and designing everything on paper and implementing, and then using with real people with a different perspective. So we need this. We will need this few months probably of feedback and testing with real people writing smart contract on the testnet in order to validate and solidify these design choices. And if we made some wrong design choices, then we change them. So we will provide a single binary, probably compiled with the -bloat command line option, because I think 300 kilobytes might be too ridiculous to many programmers. So basically, you have a C3 binary, and you just invoke it to compile the code. You can even compile and deploy directly. So you just provide domain name and a port if you work locally, or you can just write the name of a network or provide the ID of a network. So basically like mainnet, Ring-B, Robstem, Kovan, and so on. Once we have the testing generative test framework, you can invoke it also using C3 test, and it will generate for you all the tests, or run your own unit tests. We haven't specified for now the unit test framework, but we should at some point. And C3 run, that will be invoking the simulator once available to be able to switch, to run your code and maybe eventually switch in step-by-step debugger with a source level debugger. So C3 should be available on all these platforms. Later, when Red will be fully available on Android and web, you will be able to run them directly there. Yeah, running on Intel ARM. What else? C3 compiles to C3 system. Okay. Okay, these are future features that we are considering. I'm not sure we will implement them in the 1.0. The next weeks we will release the 0.1, so the first alpha of the C3 compiler. So we won't have all the features, but some enough features to start playing with. One feature that is very missing and that is very misleading to very many people that are looking at smart contract is that they think that it works a bit like a contract, a real contract. So it means that when you, because people sell the smart contract by selling it's the instead of using the court system or the paper contract as the rule, the code becomes the rule. But in order for that to be really useful in the real world, it means that the code needs to be capable of doing many things. And one basic thing is that the code should be able to run by itself. So in a contract you specify, for example, on 1st November, on 1st January, send that much to that address. You cannot do that on Ethereum. It's not a feature of the smart contract, because the smart contract cannot run by itself. The smart contract code can only run when invoked from a transaction that can be coming from a person or can be coming from another contract. So you cannot just say at given date do something, or in 10 minutes do something. That's not possible, and that's a big limitation for the use cases of smart contract.
It's like saying you have a cron system, but the computer is asleep. So the timer is not running.
So
how would you tackle this?
That's a good question. Yeah.
I have some notes. We'll when we finish this talk, we'll take a break and have some
Yeah,
snacks.
but,
And then I have some notes on the
basically,
Oracle. Again, our
basically
Oracle.
there are, yeah, that's the Oracle problem. Well,
What the blockchain people call anything outside the blockchain an oracle. If you reference any data,
Input, the input
anything
data.
from outside, those are called oracles.
something that is emitting data that can be trusted, that should be trusted inside the contract is called an oracle. And the problem is, as soon as you exit the blockchain, the EVM and the Ethereum network world, you are back in a centralized world. So the trustless and the trust that you can build from using the Ethereum network disappears immediately, and you are back to the old times, and back to the main problem, which is how do you trust some information coming in. So that's the oracle problem in all the blockchains. So there are different ways to address that. So one first way is to build a centralized server and try to make people trust you. That may work or not work. In crypto space, people are not really, usually don't like much this kind of solution. So what's the alternative to that is to use a decentralized oracle. Or in this case, where we don't have to build our own for that. There's a project called from Chronologic called.
I'll go into this after we take a break.
Okay. So there are some on the market, at least one or two. Well, one seems to be more serious than the others. From Chronologic, decentralized oracle that gives you, based on Ethereum alarm clock, and basically gives you a decentralized cron. We haven't looked into the detail to see how sound the design of that architecture is and how much we can trust it and how the synchronization happen and how accurate it is. But for example, so it has been integrated into MyCrypto. I don't know if it's on my Ethereum wallet, but it's on MyCrypto website. So when you send a transaction, you can say, oh, I want to defer this transaction in the future, not just now. And then you write some information about when you want to send this transaction, and then you get a warning message. Beware, this transaction will be run at the time you specified, plus a delay that can be around 20 minutes. That's how they, so it's probably maybe even more than that. It depends on the state of the network, I guess. So at least you get 20 minutes of unknown uncertainty for when your cron will run in the future. Yeah, that's the state of things. So we would like to bring this feature inside the language once we find a trustable and good enough infrastructure for that. Then we can build it into language directly. So like I showed you the scheduling language, we can include into C3 or C3 system this kind of construct where you can say at a point in time or in this amount of time or every something, do something, or call this function or do this transaction or whatever. And that will open a lot of use cases for real world for the smart contract usages. But for now, we are missing this infrastructure to allow this cron to run properly. Another important feature that we can do once we have IPFS and Swarm connector is to have the ability from the language C3 system to import a file, any file, hash it, store the hash on the chain, and upload the file on IPFS and Swarm. Everybody knows about IPFS? No? So IPFS is a decentralized storage space. So basically imagine Dropbox or Google Cloud or Amazon and decentralized.
It stands for Interplanetary File System.
Yeah, decentralized so that anybody can download, set up a node and allocate some storage space. And the protocol will ensure that the files are cryptographically secured and cut in pieces. and replicated over the network, so that once you download access that resource, even if some nodes are down, you can still find some copies of some pieces somewhere replicated, and just in parallel download different pieces at the same time, so you can maximize the bandwidth for that. So that's a great, very interesting feature. And Swarm is the actually, I don't know if Swarm is using IPFS as a backend. No, they're building their own separate network for that. And Swarm is the Ethereum Foundation version of IPFS, working on the same principles, basic principles. So one, I think one of the pretty much only use case I have seen so far in real world for the blockchains in general is storing a hash of an existing file on the chain, because it's a you get a timestamp, and it's in the you get a proof of the in a timeline of that timestamp. So that's the core value of a blockchain based on the Merkle tree data structures and construct. So it gives you this interesting information that you can check in the future and say, at that time we put that file was created, and with meta information eventually you can hash also. So you get a proof that nobody can modify except Vitalik. Superpowers, he can change the code on the data on the blockchain whenever he wants. So basically, that's some use cases we have seen in the real world. A company in the US doing that called ULedger. And they are signing a lot of things. For example, emails. So they sell a solution for real customers, real people, yeah. Using a blockchain. So they have their own blockchain for that, optimized for this use case. But that could be used by any kind of blockchain, where you can select emails, or by default maybe process all the emails and just calculate a hash and store that hash on the chain, so that later you can use this proof, for example, on a dispute with a customer or supplier, or in court, on court. You can use this proof to say, this email, exact email with the content unchanged, I have the proof on the chain that it was sent at that time. And you can hash the email with the header, so you have all the meta information of the email, date and everything, the sender, everything, and it's on the chain, and you can prove the date, the timestamp. So that's a real use case. So it seems like there's some need for that, and it would be cool in smart contract to add this capability directly into the C3 language, where you can just like maybe read or import or load, and the compiler will just do the work for you, take the file, hash it, generate the code to store the hash, so that when you reference the file, actually you, from the language itself, you reference just the hash, and the content of the file, eventually, if you need it, can be uploaded and stored, encrypted on the IPFS or Swarm network. And last, we already talked about it, it's the buffering, the storage accesses in memory. We are really looking into that one, because if that works, that's a pretty big feature. If we can optimize that, then we have a gain, and we can generate many contracts that are cheaper than Solidity. And if we can achieve that, it means, wow, that's a killer feature. It means that many people will just switch to our solution instead of Solidity, only because of that feature. Regardless of the rest, well, we cannot do worse than Solidity anyway. But many people will switch to that just because it enables more use cases than Solidity. So if we can achieve that, we have a win. Last, and then we stop. C3, so the high level, very high level DSL. It's very challenging to design it, because we try to make it really higher level. It means no types, no functions, no programming construct, except maybe very simple control flow. So the initial idea was to try a IFTTT model. I don't know if everybody knows about IFTTT. So it's an app you can download on your smartphone that allows you to create macro rules for operating any other apps or online services. We have connectors for pretty much everything. And you do that using if then, if
this then that.
if this then that. So basically just a if control flow where you specify a condition and then you specify an action. So we thought maybe that could be an interesting model to start for non-programmers, because IFTTT is used by everyone in the world. You don't need to be a programmer for that. It's a simple control flow model that could work. We try to apply that to a smart contract, but each time we hit a barrier, which is we don't know exactly what is the main use case in the real world for smart contracts. Who will be mostly using this smart contract and for what? Because there are a lot of vision of the future where smart contracts will be used for this, like making a contract between me and Greg. I lend some money to Greg, and Greg has to refund me in 3 rates next year, and there's a deadline for that. And we, instead of signing a paper that can be enforced on court, we will make a smart contract between us. So that's one of the possible ways it could be used by everybody. And then in such case, we need to have C3 be able to express these intents and these rules as simple as possible so that non-programmers could use that. Eventually, even having a visual tool on top of that could be mapping to that so that it could be even expressed visually. The problem is that we don't know if this kind of vision is the future, is that where the smart contract will be mostly used in the real world, in the real industry or not. For now, we don't know. We just don't know. So this is a kind of barrier, it's a kind of blocking for designing and choosing a good option. So we might end up simply trying different approaches. So designing different DSL with different properties and different approaches, and providing prototype compilers for that and giving it, putting it out and let people play with it and tell us what works or what's good or what is not. So for now we are considering a different model that is more more like closer to VID. So what we did for the visual design language for GUI creations, where you have pre-built high-level components. So for example, a token is a pre-built component written in C3 system. And token encompasses all the kind of tokens that you can have. So ERC20, 7221, so fungible, non-fungible, and all the variations, mintable, burnable, and all the different options you can have in different tokens. So we can combine all that into one high-level object called token, and with default properties. So by default, it's just a plain basic ERC20 token, and then the user can just specify options for that. Some options are mandatory, like the name and the description, and some options are optional, mintable, burnable, and then you can have some specific construct, an extension like allocations or supply, where you can provide these information so that the token can be properly instantiated for your use case. But it's still limited, but maybe good enough for a high-level language. And then eventually, we can even define events inside that high-level object. So we provide the default implementation. So for ERC20 token, we provide all the basic code in C3 system for implementing it. And then inside it, we insert some hooks for possible high-level events that could be eventually used by the user to customize the behavior. So we keep the basic ERC20 behavior because it needs to be ERC compliant, but the user can customize it if he wants. So for example, in the transfer function, for those who know the ERC20 API, there's a transfer function that is used for the main function for transferring tokens between two parties. We could provide two hooks before the transfer and after the transfer, where we can provide some limited keywords and actions, maybe like couple of dozens different actions. The main one that people could be using for doing something and customizing this token. So this is one example of the direction we are researching for now. We are still not there. I mean, we still did not decide on what the design should be, but this is where we are so far. So if you have ideas about how this could work, because we want also this high-level object to be able to interoperate with each other or combine with each other, so that in the same contract you can instantiate a token, but maybe you can instantiate an escrow object, maybe you can instantiate a voting object, and then make them interact with each other in order to build some more complex flows. But how to keep it still high level without going down into types, data structure, and so that's often where the limit is. As soon as you want to provide more features, you need lower level construct, and we want to stay pretty high level. Basically, we want to make it usable by people who have no programming background. So can that be useful enough for this kind of target people? We don't know yet. We still have to do more research on that. We thought it could be easy. We're working on this in several months, and we thought it could be pretty easy. In a few weeks we could figure out these answers, but actually no, because the domain space is still not well defined.
Do you maybe see like developing with 2 or 3 versions, like one for finance, one for IoT?
Yes, exactly. So at some point we thought maybe we are taking the wrong approach, and maybe we should just build simple DSLs that are industry specific. And so just build, instead of C3 being one high-level DSL, have a collection of DSL that are covering the main industries that are using blockchain and smart contracts.
What I was going to say a few minutes ago, when we looked at the IFT model, the obvious use case and where that's used a lot is when you're a manufacturer or a service provider and you want people to connect to your products or services to be able to macro program them. And that's not a clear space. So we kind of moved away from that. But it doesn't mean it could never work. There may be a use case for that when people start developing things and you have IoT or other things writing information to the blockchain, you want people to connect to that. That could come back. We went the FSM route because it makes more sense in a business context, and Microsoft is pursuing this heavily in their Azure Workbench approach. And we've talked about really needing to facilitate enterprise, not adoption necessarily, but experimentation. Enterprises need to be able to find out, is there a use case for blockchains for us? What can we use it for? Businesses have FOMO about blockchains right now. And we want to help them learn and experiment much more safely and less expensively and faster. Because right now if you say, well, we've got to set up a blockchain team. I have a friend who consults for Microsoft and Google and others, and he said they're paying Solidity contractors. Now, I shouldn't say this, should I?
No.
No, okay.
No, you can.
No, we don't want people to leave Red to learn Solidity. They're paying Solidity contractors $750 an hour.
Whoa.
Because they can't find them.
Nice.
And they'll pay them pretty much whatever they demand. These programmers are holding them hostage. And then they say, you know what? We just don't know. It's going to take us another month to get the contract up. It's so slow to deploy. It's the old joke of, you guys are just playing around in the office, compiling. Deploy. That's what it is. And
Wow.
we want to give people ways to find out. Will this even help us find use cases? We'd love to have use cases.
Yeah, we asked the question at the Ethereum Foundation, especially when we were at the meeting with Solidity and Viper guys. And I asked, we're interested in use cases and business application for smart contract, and if you have any, if you can give us some food for thought or anything like that. And silence, total silence. That's not a question for them. It's not a concern for them. They are concerned about improving the EVM and working on the language and making more features and fixing the issues, but they are not really concerned about that right now. And I don't even know, I hope, but I don't know if there's anyone in the Ethereum Foundation whose job is to actually do real market research to see what are the industries or what are the use cases, real use cases that could benefit from smart contract. When I say benefit, it means that using this technology, it becomes cheaper or faster or easier to do than existing solutions. And this requires a lot of work and research, and I hope, but I don't know if they are doing this kind of work. Maybe they are just waiting for the community to do that work. Yeah. Who? NEO? NEO has a very different approach. They are like the extreme, they are like the dark side. If you consider that Vitalik is Obi-Wan, Neo is like Darth Vader, or the opposite side. The Emperor, yeah. So they are not censorship resistant. They are government compliant. That's their direction. They are 100% centralized. And they are betting on the digital assets. So they are betting on tokenizing everything and building what they call a smart economy, which is just a marketing word. So it means that, tokenizing and putting everything on the chain and being able to, exchange these assets or trade these assets on the chain. Their approach is to be a good citizen in China, so that the government might select them as the official blockchain, because in China, of course, there won't be, if the blockchain become a legal thing and be used in the industry for general trading, it probably will be only one and controlled directly by the government. So they have a totally different approach to that. They might succeed in their way, but only in China or countries like China, not in the rest of the world. They have a lot of money, because their market cap is really high. But we'll see what happens, because the core team, the core founders, spawned a new project called ONT, Ontology, a new blockchain. I still don't understand why they did that, and they are focusing their effort on Ontology now, not really on Neo.
I was thinking about the visibility and the control. I was like thinking, oh, there is Ontology, you have to know about it, and you just,
Yeah.
it's so, it materializes what you just said.
Yeah, yeah. That's the direction. In China, if you want to be successful, you need to be appealing for the government. And that's what they try to achieve. So they might become very successful because they don't really have any competitor in China at that level. And they're very famous in China now. Still, it's not a relevant solution, or architecture or design choices for us in the rest of the world. So
Their approach is very different. Nena actually spoke on a panel for them in January. We were at a conference, and
at the Neo DevCon,
they asked us to participate, and they had 4 other developers, or 3 or 4.
3 other guys. It was a smart contract panel, and 3 other guys were from the Neo community and with some serious backgrounds. One was a PhD researcher at MIT. No, not MIT. Stanford.
Maybe.
Stanford, maybe. Serious guys. And so the question were about smart contract, and especially the design choices of Neo, of going with the general purpose languages. Because on Neo, you don't code with Solidity or some specific DSL. You code with Python, C#, and they plan to support JavaScript, and they plan to support Python and pretty much everything.
So it's quite a different direction, because and when they started the Viper project, Vitalik said, the point here is we have to constrain these languages. It's a completely different environment. So we're on a completely different path than the Neo people in that regard. All right. Is this the last slide?
Yeah, that's the last slide. So we can take some drinks, coffee, snacks, and
then, since we're on the blockchain side, is it okay if I do the cron thing next? I'll be pretty quick, and then we'll have Bolek talk, and then we'll do our prize giveaway.
Yeah. Thank you.
And everybody has a good chance to win a prize, because there aren't very many.
Yeah, there are many prizes. And if anyone wants to relax, we have a genuine original Galaga arcade machine. I can plug it for you, and you can try to beat my high score, but unfortunately it disappeared now because I unplugged the battery. If you can beat the high score, you can receive some extra gifts. So the high score is 150,000. I have the picture to prove it. It's on chain.